if you start with f of x, f prime of x, and I always make mine a little too straight up and down. It's actually like an apostrophe. This is your first derivative. Okay, this is our original, f of x is our original function. And if we want to do the second derivative, that means we take the derivative of the derivative and we use a double prime. And we just say second derivative. Now, if we use y as our original function, the notation where y is a function of x would be dy dx. So the derivative of y with respect to x, that's your first derivative. And then the second derivative is written d2y over dx2. And those are not squares, and that's why I'm saying d2y instead of d squared y. It's d2y. And we just say second derivative when we see that. Now, your book and the stuff you see online is going to use these interchangeably. So that's why we go over this. Okay, so example number 1 asks us for the function f of x equals 3x to the third minus 5x squared plus 11x plus 5. Find the second derivative, and the second derivative at 0 and the second derivative at 5. Now, you can't find the second derivative without first finding the first derivative. So in this one, they actually tell us to go ahead and find the first derivative. So f prime of x, using our power rule, 9x squared minus 10x plus 11. So that means we want to take the second derivative. It's going to be 18x minus 10. So when they ask us to find f double prime of 0, or the second derivative of the function f at x equals 0, we just substitute that 0 in to the second derivative expression, and we get negative 10. Now, the second derivative at 5, we just substitute in 5 into the expression. 18 times 5 minus 10. I believe that's going to be 90 minus 10. So 18 times 5, 90 minus 10 is 80. So nothing really new except for the fact that we're going ahead and taking the derivative a second time. So take the derivative of the derivative, and that's your second derivative. Now, the previous rules, like quotient rules and chain rules and power rules, product rules, still apply. So in number 2, where f of x is x squared over 1 plus x, I need to identify my numerator and my numerator derivative, so x squared and 2x. My denominator is 1 plus x. It's a binomial. I'm going to put it in parentheses. The derivative of that is just a 1, because remember, there's a 1 coefficient in front of that x. So the quotient rule says denominator derivative of the numerator minus the numerator derivative of the denominator over the denominator squared. So they don't ask us for f prime of x here, but we've got to find it. Got to find that first derivative before we can find the second one. So it's going to be denominator in parentheses, since it's a binomial, derivative of the numerator, that's times 2x, minus the numerator, x squared, derivative of the denominator, the 1, over that binomial, x plus, or 1 plus x, x plus 1, same thing, but I'll put it in the order they gave it to us, squared. Now, whereas simplification might not have been all that important in some cases, we're going to need to simplify these before we take the second derivative. So I'm going to distribute that 2x, and that's going to give me 2x plus 2x squared minus x squared, all of that over 1 plus x squared. And so that's going to give me 2x squared minus x squared is x squared plus 2x. All of that is over 1 plus x squared. Now that is my first derivative of f. To find the second derivative, I have to now identify my numerator, my denominator, and continue through with the process. So my numerator is x squared plus 2x. My numerator's derivative is 2x plus 2, and since that's a binomial, I'm going to put it in parentheses. My denominator is 1 plus x squared, and the derivative of that is the power times the base, the power minus 1, and the derivative of that base is a 1. Okay, I'll go ahead and do the chain rule, but I don't really have to. So it is 2 times 1 plus x. Now I have to assemble this. So second derivative of f with respect to x is my denominator, 1 plus x squared, the derivative of my numerator, 2x plus 2, minus the numerator, x squared plus 2x, times the derivative of the denominator. It's going to be a 2 and an x plus 1. I'm just going to put that 2 in there. This is all multiplication. And this is all over this denominator squared, which is going to be 1 plus x to the 4th. Now, they want me to evaluate this at 0. I could plug in my 0 right there, okay? But I think it's going to be a little bit better if you go ahead and do some simplification. So let's take this a little at a time and simplify this guy. Okay, so let's see. In the numerator, I'm just going to take out some stuff that's in common so I can clean it up. I do notice that both of these have an x plus 1. Okay, I'm going to start with that. I'll just get the 1 plus x, x plus 1 out of the way. Okay, now I'm going to use a big bracket for everything that's left in here. So I've taken out one of the 1 plus x's. So I need a 1 plus x. I need a 2x plus 2. I need a minus. I'm going to put the 2 in the front and an x squared plus 2x. And all of that is over 1 plus x to the 4th. Now, I immediately see a factor of 1 plus x. 1 plus x to the 4th, that's going to leave 3 of those in my denominator. Okay. So, got that simplified. And that's going to be a 1 plus x to the 3rd in the bottom. And it may simplify out some more, but that's what we have so far. Now here, I'm going to have to distribute that, you know, the FOIL rule thing. And here I'm going to have to distribute that minus 2. So I've got 2x, that's when I multiply the 1 and the 2x, plus 2, that's the 1 times the 2, plus 2x squared, plus, so this is the 2x squared, and that times that is plus 2x. Now here I have to be careful, minus 2x squared minus 4x. So I distribute the minus 2 times a positive makes this minus, and a minus 2 times that positive makes that minus. Now let's see if we can make this even simpler. I see a 2x squared and a minus 2x squared, all right? I see a 2x and a 2x, which is a 4x, and a minus 4x. So all of that leaves me with just 2 over 1 plus x cubed. And that's going to be a whole lot easier to evaluate than it would have been if we put it here in this one that's not simplified. Now remember what they ask us to find. They ask us to find second derivative at 0 and the second derivative at 7. Okay. So now that I have that easy to evaluate expression, I will just plug it in. If I put a 0 in there, I get 2 over 1 plus 0 to the third. That's 2 over 1 to the third. 2 over 1 is 2. And if I put a 7 in there, that's 2 over 1 plus 7 to the third. That's 2 over 8 cubed. 8 cubed is 512, so that's 2 over 512, which reduces to 2 over 256. So there I have evaluated my second derivative at 0 and at 7. So our answers for this one was, we got 2 over 1 plus x cubed here. F double prime of 0, we got 2, and F double prime of 7, we got 1 over 256. And I really should just be saying the second derivative, but it's a habit, and you can say it also as long as you know that double prime means second derivative. All right, let's try another one. Number 3. For the function f of x equals the square root of x squared plus 36, find the second derivative of f of x, then find the second derivative at 0 and the second derivative at 7. All right, so you got the square root function, so remember what you have to do. You have to write the radicand, the numbers inside, or expression in this case inside, to the 1/2 power. First, you do the first derivative. So f prime of x is power 1/2 base 1/2 minus 1, derivative of the base 2x. That's a chain rule. Since this interior has a derivative, you've got to chain that on. I see a 2 in the bottom and a 2 in the top. So that's going to give me, look, this x is going to be on top. And that square root, x squared plus 36, I'm going to leave it with a 1/2 power, is going to be in the denominator. Now, you can leave it as x times x squared plus 36 to the negative 1/2. Now, remember where I got that. Half minus 1 is negative 1/2. So we can either be in the denominator with a positive or in the numerator with a negative. So you could either use the quotient rule or you can use the product rule, right, when we're doing our second derivative. So our first derivative is, and my math lab should take either one of these, x over x squared plus 36 to the 1/2. Now I'm going to do the second derivative. So I'm going to create some space on the next page. So this is our first derivative, f prime of x. And I'm using the quotient rule here. So my numerator is x. The derivative, first derivative of my numerator is 1. So this is just like taking the first derivative, only you're taking the derivative of the derivative. My denominator is x squared plus 36 to the 1/2. Don't forget your exponent there. And the derivative of that is just like we found a minute ago. 1/2, that's the power, times the base to the power minus 1, which is negative 1/2, times the derivative of the base. That's the most commonly forgotten part. You've got to do your chain rule. These cancel out, and I end up with x over x squared plus 36 to the 1/2, which is exactly what we started with, but that is just the derivative of the denominator. So now I have to assemble my quotient rule. Denominator, derivative of the numerator, minus numerator, derivative of the denominator over the denominator squared. So my denominator, that's the original one, x squared plus 36 to the 1/2. The derivative of the numerator, thankfully, is just a 1. I don't even have to write that. Minus my numerator, which is an x, and the derivative of the denominator. Now, let's be careful here. It's going to be x over x squared plus 36 to the 1/2. All of that is over x squared plus 36 to the 1/2 squared. And when you multiply raise a power to a power, we multiply those, and so we just end up with our denominator of x squared plus 36 to the 1, because 1/2 times 2 is 1. Now I'm going to clean up my numerator a little bit, and I'm going to go ahead and I'm going to write that second one with a negative exponent so that I don't have a complex fraction. I don't want a fraction in a fraction. I'm going to write that as an x squared, x times x, and then I'm going to write x squared plus 36 to the minus 1/2. Now, they do ask us to find f prime of 0 and f double prime of 7. So second derivative at 7. Oh, it's second derivative at 0 and second derivative at 7. Now, you could go ahead and put it in here. I'm going to show you how to factor it, and I think that you would probably be okay if you enter that in MyMathLab carefully, or you could try to simplify it. Now, remember when you have factoring, let's say I have x cubed plus x squared, and I want to take out the greatest common factor, I have to take out the lowest exponent, okay, or the smallest exponent, I guess I can say. The smallest exponent is all I can take out. So here I can only take out an x squared because the second term here only has an x squared. I can't take out an x cubed if I don't have that many. So if I look at these two, 1/2 and negative 1/2, negative 1/2 is the smallest one. I'm going to take out x squared plus 36 to the negative 1/2. Now, what am I going to get in here when I do that? I'm going to go ahead and write my x squared plus 36 here. Now, remember, when we did this easier one, these two exponents have to add up to 3. So you can take the 3 exponent minus the 2 exponent. It'll tell you what's left in here. So I've got to take the negative 1/2 exponent, which is the smallest, and I've got to be able to add it together, add these two together to get the overall one. So to get a positive 1/2, I'm going to need an x squared plus 36 to the 1. Because look, this exponent is a positive 1/2. These two have to add to a positive 1/2. Or you can take 1/2 minus negative 1/2, and that's where we get the 1, just like I did 3 minus 2 to get a 1 there. Here, I've taken out this whole thing, so that's just going to be a minus x squared. All right, so this simplifies down pretty nicely. X squared plus 36 to the negative 1/2. And look, this 1 exponent means I don't even need these parentheses at all, because that's just x squared plus 36 minus x squared. That's a 36 over x squared plus 36. And now I'm going to take this negative exponent to my denominator. So the 36 stays on top. And I have x squared plus 36 to the positive 1/2 and x squared plus 36. Now remember, when you have two bases being multiplied, you keep the base the same and you add the exponents. So this is going to be 36 over x squared plus 36. Remember, there's a 1 there, and 1/2 plus 1 is 1/2 plus 2 over 2, so this is 3/2. And that is the simplified version of the second derivative. This is the second derivative of f. Now, evaluating it as 0 is pretty easy. Second derivative at 0 is 36 over 0 squared plus 36 to the 3/2. That's 36. And you might want to leave it as the square root of that and that to the 1 instead of having to do the 3/2. But you can do this on your calculator. You can do 36 raised to the 3/2. Now, if you want to use a division key, you're going to have to put parentheses. If you use the fraction key, I'm pretty sure that it will be okay, because it'll keep that 3/2 together. So I'm going to do it on my calculator. It really means the square root of 36 to the third. So it means 6 to the third. Should come out to 216. Let's see, 36 raised to the 3 fraction key 2 is 216. And then 36 fraction key 216 reduces to 1/6. So the second derivative at 0 is 1/6. Now we have to do it at 7. The second derivative at 7 is 36 divided by 7 squared plus 36 to the 3/2. That's 36, 49, and 36, 96, 15, that's 85 to the 3/2. And it says to us to do this one as a decimal. So let's see, 36 divided by 85 raised to the 3 divided by 2 is approximately 0.045938. They ask it to be 2 decimal places, so 0.05. And that's our example number 3. So I'll fill these in. For the derivative, we got, first derivative, we got that. For second derivative, we got 36 over x squared plus 36 to the 3/2. For this one, we got 1/6. For this one, we got 0.05. Example number 4. For f of x equals negative x to the 2/3, find the second derivative and then the second derivative of 0, 1, and negative 1. So this one shouldn't be as bad as that last one because it's just a power rule. So it's going to be, for the first derivative, minus 2/3 x to the 2/3 minus 1. So it's minus 2/3 x to the minus 1/3. I'm just going to leave it just like that. second derivative is going to be minus 2/3 times the power, base power minus 1. So a negative and negative is going to be 2/9 x to the negative 4/3. So I did negative 1/3 minus 3/3, because that's 1, it's negative 4/3. And again, use your calculator. So our second derivative was 2/9 x to the negative 2/3, and you could write that, if you wanted to put that x in the denominator, this one's fine, but you could also do 2/9 x to the 4/3. So I'll put it in that way. Now, again, that x to the 4/3 means you take the cube root of x, and whatever you get, you raise it to the 4th power. Okay, like up here, the 3/2 means the square root of, if we had x to the 3/2, the square root of x, and then raise it to the 3rd. So we're going to have to do that here. So if I do second derivative at 0, I get 2/9, 0 to the 4/3. And you'll notice that that gives me 2/0. Well, that's undefined, right? 0 denominator is always undefined. Now at 1, it's going to be 2/9 times 1 to the 4/3. 1 to any power is 1, so that's 2/9. Okay. And now let's do f double prime, or the second derivative of f at -1. It's 2/9 -1 to the 4/3. Since we're taking the cube root, it's going to be negative, but then we're going to raise it to the 4th. It's going to be positive. So that is also going to be 2/9. All right. So look, I did the cube root of -1, then I raised it to the 4th, is -1 to an even power. It's going to be a positive 1. So 9 times 1 is where I got the 9. Example 5, we have a function with e. And remember, e is just a value like pi. It's 3.14 approximately. E is about 2.7. So we're going to take its derivative, and we've got to use the chain rule. Remember, if f of x is e to some function, then the first derivative is you copy it just as is, and then you take the derivative of the exponent. So for us, f of x is 3e to the negative x to the 4th. So the first derivative is 3e to the negative x to the 4th times negative 4x to the 3rd, right? So we got -1x to the 4th. That's going to be -1 times 4, x to the 4 minus 1. So it's -4x to the 3rd. Now I'm going to clean it up a little bit so it'll make the next derivative easier. Okay, so 3 times -4 is -12. X cubed, I'm going to put that one first, e to the negative x to the 4th. And look, this is going to be a product rule. Okay, and we could have done the one just like above and done the product rule with that one as well. So you don't have to simplify it before you take the second derivative. Okay, so my first one, I'm going to write it over here, is -12 x to the 3rd. So that derivative is negative 36x squared. My second one is e to the negative x to the fourth. So that's what we got. Look, when we did e to the negative x to the fourth before, we're going to get negative 4x third e to the negative x to the fourth. Right, because that's your chain rule, that negative 4x to the third. So I'm going to assemble. F second derivative is the first, negative 12x to the third, times the derivative of the second. I'll use parentheses for now. You could use a dot, but negative 4x to the third, e to the negative x to the fourth. First, derivative second, plus the second, e to the negative x to the fourth, derivative of the first, use parentheses, negative 36x squared. All right, so here I've got a monomial times a monomial. So let's see, that's going to be a negative and a negative, so that's going to be a positive 48. Now I've got x to the sixth, e to the negative x to the fourth, minus 36x squared, e to the negative x to the fourth. Now, we could clean this up a little bit. Let's see what we can do. 48 and 36 have a common factor of 12. X to the sixth and x squared have a common factor of x squared. And look, we also have a factor that is the same in both, e to the negative x to the fourth. So I'm doing my greatest common factor. Now, what's left over? Well, the 12 goes into 48. I need a 4. I'm going to need an x to the fourth. And I don't need an e to anything because I've already brought up the e to the negative x to the fourth. Here I need a minus 3. And let's see, the x squared is already out, and the e to the negative x to the fourth is already out. So that's all I need right there. So that's my simplified second derivative. So that's what I would have to write for second derivative. 12x squared, e to the negative x to the fourth, times 4x to the fourth minus 3. Now, if I put a 0 in there, look, this is going to be 0. If that's a 0, x 0 squared, that's going to be 12 times 0 times e to that, and that didn't matter. It's going to be a 0. So this is just going to be a 0. So f double prime of 0, second derivative at 0. Look, 12, 0 squared, e to the negative 0 to the fourth, 4 times 0 to the fourth minus 3. Well, that's going to be 12 times 0 times e to the 0 times 0 minus 3. But look, that 0 right there makes this whole thing 0. And now they want us to do the second derivative at 1. So let's see, we've got 12, 1 squared, e to the negative 1 to the fourth, 4, negative 1 to the fourth, minus 3. If you got those parentheses right, you can just type this in. I'll do it the manual way. It's a 12. That's a 1. Now, this is tricky. Negative 1 to the fourth. Because, look, it's opposite of x to the fourth. And you put parentheses just where the x is. Okay? So, the 1 goes in just here. That's going to be negative 1. And I know that's going to be the one that a lot of folks miss, so you got to be careful. Now, this is going to be just positive 1, so that's going to be a 4 minus 3. So it's 12 e to the negative 1 times 1. which is 12 over e to the 1, or 12 divided by e. And they want us to give a decimal for this one. So 12 divided by, and you got an e key on your calculator, so do second natural log and tell it is e to the 1, and then you get 4, and let's see, they say do it to 4 decimal places. See right here? 4 decimal places. So 4.4146.